In 2003, every expert in the automotive industry knew one thing for certain. You couldn't build a real electric car with laptop batteries. It was dangerous. It violated every principle of proper battery design. Traditional wisdom said you needed big, specialized automotive cells, not thousands of tiny consumer batteries wired together like some kind of science experiment. But one engineer didn't care what the experts thought. J.B. Straubel, one of the later co-founders of Tesla Motors, looked at those small cylindrical lithium-ion cells sitting inside every laptop and saw something nobody else could see: the future of transportation. His crazy idea to use 6,831 laptop batteries to power a sports car wasn't just unconventional. It was the kind of thinking that could either revolutionize the industry or turn Tesla into the world's most expensive fireworks display. When Straubel pitched this concept, people told him he was insane. Battery engineers laughed at him. Automotive executives dismissed him. Even his friends at Stanford thought he'd lost his mind. But Straubel had done the math. He knew lithium-ion technology had reached a tipping point. And when he finally found someone willing to listen, a PayPal billionaire named Elon Musk, everything changed. Together, they built the Tesla Roadster on a foundation that the entire industry said couldn't work. But there was one massive problem they didn't anticipate. Those thousands of tiny batteries could explode. And if just one caught fire, the entire pack would turn into a chain reaction that could incinerate the car and everyone inside it. This is the story of how Straubel's backwards battery design almost destroyed Tesla before saving it. Jeffrey Brian Straubel was born on December 20th, 1975, and grew up with an obsession that most kids couldn't understand. While other teenagers were playing video games, Straubel was in his garage, taking apart golf carts and building electric vehicles. He wasn't just tinkering. He was studying energy systems with the intensity of someone decades older. His family thought it was a phase. It wasn't. Straubel earned his way into Stanford University, where he pursued a self-designed major in energy systems engineering. One of his professors later called him one of the most amazing students to cross my path in the past decade. But Straubel wasn't satisfied with just classroom learning. He joined Stanford's solar car racing team and started one of the most ambitious personal projects imaginable: converting a Porsche 944 into a high-performance electric vehicle. The rebuild was incredible. Electric motors transfer torque to wheels far more efficiently than combustion engines, so Straubel's electric Porsche had jaw-dropping acceleration. But there was one massive problem. The car used heavy, outdated lead-acid batteries that could barely push the vehicle 30 miles on a charge. Straubel had created a rocket ship with a gas tank the size of a coffee cup. He needed better battery technology. And in the early 2000s, he found it. Around 2002, Straubel noticed something that would change his life. Lithium-ion batteries, the kind powering laptops and cell phones, had improved dramatically. They were lighter, more energy-dense, and far more reliable than the lead-acid batteries everyone used in electric vehicles. Most people saw these as consumer electronics components. Straubel saw them as the key to making electric cars viable. He became convinced that you could string together thousands of these small cells into a battery pack powerful enough to give a car hundreds of miles of range. The idea was completely backwards from conventional automotive battery design. Traditional thinking said you should use fewer, larger cells specifically engineered for vehicles. Using thousands of tiny laptop batteries seemed insane. But Straubel understood something the experts missed. Smaller cells are easier to cool, safer to manage individually, and could be manufactured at massive scale because the consumer electronics industry was already making billions of them. In early 2003, Straubel was working at an electric aircraft startup called Volocom. He and his boss, satellite pioneer Harold Rosen, wanted to convince someone with deep pockets to invest in their hydrogen-powered electric airplane concept. They reached out to Elon Musk, the billionaire who had just sold PayPal and was now building rockets with SpaceX. Musk agreed to meet them for lunch at McCormick & Schmick's seafood restaurant in El Segundo, just down the street from SpaceX headquarters. The lunch didn't go as planned. Musk wasn't interested in electric airplanes at all, but when Straubel mentioned his discovery about lithium-ion batteries and electric cars, everything changed. Musk had been obsessed with electric vehicles for years. He'd even come to California originally to pursue a PhD at Stanford researching high-density capacitors for EVs before dropping out to start companies. When Musk heard that battery technology had advanced enough to make a practical electric car possible, he was immediately hooked. Straubel later recalled that moment. "Everyone else had told me I was crazy, but Elon loved the idea." Musk understood the potential better than anyone else Straubel had talked to. But Musk wanted proof, so Straubel took him to test drive a prototype electric sports car called the T0, built by a company called AC Propulsion. The T0 was rough. It didn't have doors or a roof, the battery cooling system barely worked, and it needed constant engineering attention just to function. But when Musk drove it, he felt the future, the instant torque, the silent acceleration, the raw power of electric propulsion. It was incredible. Musk immediately tried to convince AC Propulsion to commercialize the T0. He practically begged them, but they refused. They were engineers, not entrepreneurs. They didn't want to build a car company. So Musk asked them a simple question. "If you're not going to commercialize this, do you mind if I do it?" AC Propulsion introduced Musk to Martin Eberhard and Mark Tarpenning, who had already incorporated a company called Tesla Motors based on the same concept, and were looking for funding. In February 2004, Musk invested $6.5 million into Tesla, providing essentially the entire Series A funding round. A few months later, Straubel got a call from Musk asking if he wanted to join Tesla. Straubel joined as employee number 5 in May 2004, becoming the company's inaugural chief technology officer and one of the 5 official co-founders. He was the engineer responsible for turning Musk's vision into reality. His first major decision would define Tesla forever, building the entire car's battery pack out of thousands of laptop batteries. Straubel's battery strategy was brilliant in theory, but terrifying in practice. The Tesla Roadster would use 6,831 small cylindrical lithium-ion cells, the 18650 format that was already being mass-produced for laptops. Each cell was about the size and shape of a AA battery. By wiring thousands of them together, Straubel could create a battery pack with incredible energy density at a fraction of the cost of custom automotive cells. But there was a problem that kept Straubel up at night. Lithium-ion cells can combust if they're pierced, crushed, overcharged, or overheated. With 6,831 cells packed together, the risk multiplied exponentially. And then in 2006, laptop manufacturers started recalling millions of batteries because of spontaneous fires caused by microscopic manufacturing defects. Suddenly, Straubel's battery pack looked less like innovation and more like a disaster waiting to happen. Using computer models, Straubel discovered something horrifying. If any single cell caught fire due to a manufacturing defect, it could heat up the cells next to it. Those cells would then catch fire, heating up their neighbors, starting a catastrophic chain reaction that would destroy the entire battery pack and turn the car into a smoldering wreck. Tesla co-founder Mark Tarpenning asked Straubel the question everyone was thinking. "So, JB, what's going to happen to our energy storage system?" The answer came from an argument Straubel had won months earlier. When Tesla first designed the battery pack, the plan was to use air cooling to control temperature and extend battery life. It was simpler and cheaper than liquid cooling, but Straubel fought hard against that approach. He knew air cooling wouldn't provide the precise temperature control needed to keep thousands of cells operating safely. "We had a lot of heated discussions about what direction we should go," Straubel later said. But his cool-headed logic and hard data won the argument. Straubel insisted on building a sophisticated liquid cooling system. The system Straubel designed was engineering genius. He created a network of tubes filled with a 50-50 mixture of water and ethylene glycol that ran past almost every single cell in the battery pack. This liquid cooling system didn't just keep the batteries at optimal temperature during normal operation. It also provided the solution to the fire problem. By slightly improving the cooling system, Straubel's team was able to evacuate heat from a burning cell so quickly that it couldn't set off its neighbors. The liquid cooling would absorb the thermal energy before it could spread, breaking the chain reaction before it started. It was the perfect example of Straubel's engineering philosophy: anticipate problems before they become disasters. If Tesla had gone with air cooling, like most of the team wanted, the Roadster would have been a death trap. But because Straubel insisted on liquid cooling early in the design process, he had the infrastructure in place to solve a problem they didn't even know existed yet. Having a solution was one thing. Convincing the world that Tesla's battery pack was safe was another challenge entirely. In 2006 and 2007, laptop batteries were catching fire left and right. Millions were being recalled. The media was having a field day with stories about exploding electronics. And here was Tesla, a tiny startup, claiming they'd solved the problem that Sony, Dell, and every other major electronics company was struggling with. The skepticism was intense. Battery experts openly questioned whether Tesla's approach could work. Automotive engineers dismissed the laptop battery concept as amateurish. Insurance companies were nervous about covering the vehicles, and potential customers wondered if they were buying a car or a fire hazard. Straubel needed to prove them all wrong. He spent months in meetings with battery manufacturers, particularly Sanyo in Japan, one of the world's leading lithium-ion producers. Following a series of lengthy discussions in 2007, Straubel managed to convince Sanyo's engineers that Tesla had developed a way to produce lithium-ion battery-powered cars that wouldn't be rolling chemical bombs. He showed them the thermal management system, the individual cell monitoring, the safety protocols, and the extensive testing data. Slowly, the tide began to turn. Tesla also began working directly with Panasonic to optimize the cells specifically for automotive use. While the media kept calling them laptop batteries, that wasn't entirely accurate. Starting in 2010, Tesla and Panasonic collaborated to create custom 18650 cells engineered to automotive standards, with higher reliability and safety requirements than consumer electronics. "We've totally custom engineered that cell working jointly with Panasonic to create an automotive cell tested to automotive standards," Straubel explained, somewhat testily to reporters who kept calling them off-the-shelf laptop batteries. The validation finally came when Tesla started shipping Roadsters in 2008. The cars didn't explode. They didn't catch fire. In fact, as data accumulated over the years, Tesla's battery packs proved to be statistically safer than gasoline tanks in internal combustion vehicles. Straubel's backwards approach had worked. The industry experts who said it couldn't be done were forced to admit they were wrong. Straubel's laptop battery strategy didn't just save Tesla. It revolutionized the entire electric vehicle industry. By using small cylindrical cells instead of large pouch cells, Straubel created several massive advantages that other automakers couldn't match. First, cost. Because 18650 cells were already being manufactured by the billions for consumer electronics, Tesla could buy them at dramatically lower prices than custom automotive cells. This economies of scale advantage gave Tesla a cost per kilowatt hour that was years ahead of competitors. By 2016, industry analysts were calling Straubel the world's foremost expert in battery technology.
noting that Tesla had the largest database of lithium-ion battery performance data of any company on Earth. Second, thermal management. Straubel's insight about cooling was absolutely correct. Small cylindrical cells have far more surface area relative to their volume than large pouch cells, making them much easier to cool efficiently. Think about trying to cool a giant steak versus cutting it up into tiny pieces. The tiny pieces cool much faster because the coolant can reach more surface area. This superior cooling allowed Tesla's batteries to charge faster, discharge more power, and last longer than competitors. Third, safety. With small individual cells, Straubel could monitor and control each one separately. If a single cell failed, the system could isolate it and prevent the failure from spreading. Today, cylindrical cells have become one of the dominant formats in the EV industry, validating the backwards design that everyone once mocked. Straubel didn't stop innovating after the Roadster. He led the battery development for every Tesla vehicle that followed, constantly pushing the boundaries of what was possible. For the Model S, he designed a battery pack that placed all the car's weight at the bottom, creating the first vehicle that physically couldn't flip over due to its low center of gravity. The liquid cooling system became even more sophisticated, allowing Tesla to offer battery packs with ranges approaching 400 miles. He also solved the charging problem that skeptics said would kill electric vehicles. Straubel lobbied hard for Tesla to build its own supercharger network instead of pursuing battery swapping technology, which many people thought was the future. Straubel understood that fast DC charging was more practical and would give Tesla control over the customer experience. Today, Tesla's supercharger network, available exclusively to Tesla drivers, is the largest fast-charging network in the world and a massive competitive advantage. Perhaps Straubel's most important contribution was the Gigafactory concept. In the mid-2010s, as Tesla ramped up production, Straubel realized they would face a massive bottleneck. The entire world's production of lithium-ion batteries wasn't enough to supply Tesla's ambitions. So he led the development of Gigafactory Nevada, a massive facility designed to produce more batteries than the entire world had manufactured in 2013. Through it all, Straubel remained the quiet genius behind the scenes. While Musk became one of the most famous entrepreneurs on Earth, Straubel stayed out of the spotlight, focusing on the engineering challenges. His name appeared on the majority of Tesla's patents, especially those relating to batteries, safety, architecture, monitoring, and power management. Gene Berdichevsky, Tesla employee number 7, said it best, "JB is absolutely brilliant. When I started, we did some of the technical development in his garage." In July 2019, Straubel shocked the automotive world by announcing he was stepping down as Tesla's chief technology officer. He would transition to a senior advisor role with Drew Baglino, whom Straubel had recruited to Tesla in 2006, taking over as CTO. Musk was effusive in his praise during the announcement. "If we hadn't had lunch in 2003, Tesla wouldn't exist, basically." Many people wondered why Straubel was leaving at the height of Tesla's success. Some speculated he was burned out. Others thought there might be tension with Musk. But Straubel's explanation was simpler. He wanted to build new things. Tesla has evolved. What we need now is a focus on sales, delivery, and manufacturing, Straubel said in an interview. "I have been helping with that in recent years, but it's not what I am best at. There are people in the world who are better at this stuff and enjoy it more." The truth was that Straubel had started thinking about a new problem years earlier. In 2017, while still at Tesla, he founded a company called Redwood Materials, working on battery recycling and creating a circular supply chain for battery materials. It's both inspiring and terrifying to see so many nations and car companies announcing their shift to electric vehicles, Straubel explained. Straubel realized that if electric vehicles truly took over the world, there would soon be a massive shortage of lithium, nickel, cobalt, and copper. Today, Redwood Materials has become the largest lithium-ion battery recycler in the United States. The company can recover greater than 95% of critical battery elements from end-of-life batteries and use those metals to manufacture new battery components. In May 2023, Tesla invited Straubel to rejoin the company, but this time as a member of the board of directors. It was a fitting recognition of his contributions. Straubel's backwards battery design didn't just save Tesla, it changed the trajectory of the entire automotive industry, accelerated the transition to sustainable transportation, and proved that sometimes the craziest ideas are the ones that change the world. When you drive a Tesla today, or really any modern electric vehicle, you're experiencing the legacy of J.B. Straubel, the co-founder whose backwards thinking made it all possible. His decision to use thousands of small cylindrical cells instead of a few large custom batteries wasn't just unconventional. Every expert said you couldn't build a car with laptop batteries. But one engineer looked at those tiny cells and saw what nobody else could see. He saw a way to make electric vehicles affordable, safe, and capable of changing the world. And when everyone told him his design was backwards, he built it anyway and proved them all wrong. That's the real story of how Tesla was saved. Not by following the rules, but by an engineer who was willing to break them.